Hello everyone, this is Lakshita and welcome to my YouTube channel. And from today onwards, I'm going to upload one video every single day. Like I'm going to start working on my data structures and algorithms. So I thought why shouldn't I just explain it in a video and then upload that video. Maybe that could be helpful to someone else. So I thought that way and started my DSA journey from today onwards, and I believe consistency is the key, and I believe I can do this, and you people also can learn with me. If you feel you can understand what I'm explaining, then you could just learn and code with me. If you are not getting anything and you want to learn, you can just comment below. I can help you with whatever that you ask. So, initially, we are starting with arrays. Yes. I hope to start with data structures and algorithms, we must learn a language initially. It might be C++ or Java. I'm comfortable with C++, so I'm continuing with that. And I hope you people have also learned any one language and syntax of it, so that we could start learning the concepts of data structures and algorithms. So, throughout this journey, we'll try to learn many concepts of data structures and algorithms, try to solve many problems in various platforms, and I hope doing along with me may also help you. That is what I'm saying. Okay, let's start with the arrays concept today. Today, I have studied array. What is an array? Initially, we need to define an array. So, what is an array? An array is a collection of similar elements. Okay, an array is a collection of elements of similar data type. For example, this is an array. How can we say this an array? We will collect many elements. Suppose we have numbers, suppose 1 2 3 4 and so on up to 10. We have these numbers. We wanted to store these numbers at a single like in a contiguous manner. We want to store them. If we store them in a variable like a equals 1 or a b equals 2, we cannot access them properly, right? So to access them very neatly properly, we are just storing them in something called an array. An array is a data structure. It is a collection of elements of similar data type. This is an array which is going to have indexes. The index of an array starts from 0 to and so on up to n. So we can store these elements in this array 1 2 3 4 5 and so on. We can store them. Okay, and we must store all the elements. If we are storing in some elements in an array, those elements must be of same data type. Here we can observe that these elements are of integer. If we want to store some decimal type of data, something, if we want to store any data that is in float, then we can store them in a different array. We cannot store 0.51 and a character a. Such a in this way we cannot store in an array. An array must contain all the elements of similar data type. The data type here is integer. If we remove these and if we add something like 1.2, this data type here is float. Yeah, I hope you are getting. This is what an array is. An array is a collection of elements of similar data type in a contiguous memory location. All of them are stored in a contiguous memory location. For example, this index is 0. Suppose the address of this particular array is 1000, then its address will be 1000 plus the data type address. Suppose an integer will contain 4 bytes, right? So it will be 1004. This 3 will be placed at 1008. This 4 will be placed at 1012. This is how we'll store the elements in an array. Okay. To now we'll see how to declare array in C++ or C language. Both of them it is same. We'll write the data type, like in what type of data that we want to store in an array. we'll write the data type, and then we'll write the name of an array. Suppose I'm creating an array named a of 5. That means we are creating an array which will store 5 integer elements, like it will store only integers, and it is having 5 boxes. Here in the sense it can store 5 elements of integers. Okay, and the indexes are like 0, 1, 2, 3, 4. So this is nothing but we are declaring an array. So this is declaration of an array. To initialize an array, we can write something like a of 0 equals 1. A of 0 means array of 0. So we are accessing the 0th indexed array box. So we are storing 1 here. This way we can store the elements. Or if we want to do both initialization and declaration at a single time, then we can use this. We can write int. Suppose I want to create another different array named marks of 10 students equals, you can write it as 90, 100, 98, 94, 96, 95, or you can store less number also. Here you can observe that we have wrote that 10 elements will be stored in this array, but we can store lesser elements also. But if we declare this as 5 and store more number of elements, then it is not possible. You need to understand that. Yeah, this is what we can observe in case of an array. Now I'll show you. You just see. How are we actually doing? We are creating an array int marks of 50. This is declaring an array. This is initializing and declaring at once. Marks of 50 equals 1, 2, 3. If we don't want to write this like how many things we are going to declare, we can write without the number. But we cannot write it while simply declaring. We can write it only when we are initializing immediately after declaring. Then only we can write it as freely. Yes. Here memory is statically allocated, not dynamically. That means memory is allocated at compile time only, not at the runtime. If we want to find out the number of elements or number of elements that are present in an array, or the length, if we don't know how many elements are there, if we just wrote something like we don't know initially what we have declared, we just imagine that we have forgot what we have declared, then how to find the number of elements in an array or the length or size of an array can be found using size of array. That means here we write the array name by size of integer. Integer in the sense here we are using integer. Here we'll write the array name, that is marks. Here we'll write the data type. Here it is integer. It might be float or char or some other thing also. Yeah. Now to find the largest element in an array. Suppose that we want to find the largest element in an array. Largest element in an array. Okay. Suppose we are having these many elements: 10, 20, 15, 12, 30, and then 6. These are the elements present in an array, and we want to find out the largest element in an array. We can observe here clearly that 30 is the largest element in this array. But how can we find it using code? We are going to use a for loop here. So for int I equals 0, I less than or equals to n, or we should take less than n, I plus plus. I will tell you why only less than n. Here the index will be like 0, 1, 2, 3, 4, 5. But the n value will be 6. N is nothing but how many elements are there. Here you can see how many elements are there. 1, 2, 3, 4, 5, 6 elements are there. But the index will end at 5, because it is starting from 0, right? So since the index is starting from 0, always it will end up at n minus 1 only. This will be n minus 1, that is 6 minus 1, 5. The index will be n minus 1, that is 5. N here means the length of the array. Length of the array is 6. Okay. Now I, from I0 to I less than 6, that means I0 to 0, for 0, I0, for I1, for I2, for I3, for I4, for I5, till then the for loop runs. We'll write a condition here. If array of I, suppose this is array, this name is also array, ARR, array of I is greater than max. Initially we'll write int max equals 0. If we have found a number which is greater than max, then replace that value with max. So what we are trying to do here, this is 10, this is 20, 15, 12, 30 and 6. Initially max equals 0. So we'll the for loop runs because 0 is less than 6. Since 0 is less than 6, it will come inside. It will check the if condition. Array of I is greater than max. Array of I means here 10. Array of 0, which means 10. 10 is greater than 0. Yes, 10 is greater than 0. So max will be replaced by 10. Initially it used to be 0. Now it will be replaced by 10. So max value is 10 now. When after again it runs, I becomes I plus plus, that is I equals 1. So 1 is less than 6. So array of 1 is means 20. So 20 is greater than 10. So max value will be replaced by 20. Again this happens and we'll finally get the largest number as 30. Okay. This is what we can see. Now if we want to pass an array to a function, like if we want to in the function definition we'll write, right? While writing the function definition, we'll take it as int array of, we'll take the bracket here. Okay, close brackets here. We'll take the close brackets here. But while writing, if you don't want to write the close brackets, instead we can use the star, because array is a pointer. Okay, in C++ array name is a pointer. Here we are writing marks, right? This marks will act as a pointer. And I suppose that you know how to implement linear search. Linear search means, I'll tell you once in a simpler way. Like for suppose this is 3 4 5 1 2 6. This is for I equals 0, I less than n, I plus plus. This is the code for linear search. If we want to find out a key element and the key element is 5, array of I double equals key, then we'll return true. Okay, now you observe carefully. Array of 0 means 3. This 3 is less than, we'll check if this 3 is equals to 5. We can see that this 3 is not equals to 5, right? So it won't go into if loop. Again it will run. We'll check for 4 double equals 5. No, it is not. Again it will run. This 5 double equals 5. Yes, array of I double equals key. So we have finally found the key element. So we'll return true, that this we have found the element. This is nothing but linear search. There we are. If for suppose we have got the key element 5 here, if suppose that this 5 is present at the end of the array, suppose if it is presented here, then to find the key element we need to search throughout the array. Like if this array is having n elements, then we must search for n elements, right? So the time complexity is big of n. Okay, that is linear search. Now we'll see how to implement reversing an array. To reverse an array, we can use two methods, that is with extra space and without extra space. To reverse an array with extra space, we'll do this way. Like we'll copy from the this is the original array. This is for, suppose it is 1, 2 and then 3. Hope it is visible. 1, 2 and 3. And later we'll copy that exact thing into a different array, like 3 here, 2 into here, then 1 again to here. Okay, we'll take a for loop. We'll write j equals n minus I minus 1. J equals n minus I minus 1 means if I equals to 0, j will be here. If for a bigger thing, if we see, you can understand it more clearly. You see here, if I is here, j is here. 0, 1, 2, 3, 4, 5, 6. When I is 0, j is n minus I minus 1. Nothing but n minus 1 minus I. N minus 1 means the n minus 1 value is always, n value is 7. N minus 1 is always 6. 6 minus 0 is 6 only. So the j will stay here. When I equals 1, the j value will be like 6 minus 1, which is 5. So j would come here. So when I is moving, j is moving this way. So this is what we are doing. We are writing I and then j. We are just writing, this is our original array and this is our copied array. Copy array. We are just copying these ending values here. Array of j means this one. Array of I means this one. So we are copying this value to the copy array. And again we are printing the copy array here. This is with extra space. And without extra space means we'll take 2 pointers. As we are taking 2 pointers here, I and j, we can use that as f and l. This is first and this is last. You can use them like that, f and l. When we are reaching both of them, we can just swap these elements. We are swapping one, if it is 1 and 3 initially, we'll make it as 3 and 1. Then also when we are swapping, eventually the entire array will get reversed, right? That is what we are trying to do in the 2-pointer approach. We are taking a start as 0, end as n minus 1. We are writing code for while start is less than end, swap the value of start comma end, and you just do start plus plus and n minus minus. This is how we'll write the code for reversing an array without extra space. And this is binary search. To implement binary search, this is the best way. Like previously we have seen how to implement linear search, right? Now we'll say how to implement binary search. Just observe what is happening here. If we have the key element is 5 and we have these many elements in an array. Okay, suppose that this is 10, this is 20, this is 50, this is 90, this is 95, this is 100, this is 110, this is 500, and they want us to find the 50, key 50. The key they have given us is 50 and we need to find 50. So to do that, initially what we'll do is something like, in the linear search we are proceeding this way, right? If 50 is at the ending, we need to move from here to here. That means the for loop must run from 0 to n. So to reduce the time complexity, what we are trying to do is something like, and we must understand one thing, that binary search will only get implemented if this is binary search. Binary search will only get implemented if it is in sorted if it is a sorted array. Sorted means all of them are either in the increasing order or in the decreasing order. Now here you can observe all the elements are in increasing order, ascending order. So this is a sorted array. We can implement binary search. Yes, we can implement binary search. So to implement binary search, we'll take mid. Mid means initially f will be here, l will be here. We'll implement f plus l by 2. What is f plus l by 2? The indexes are something like 0 plus 7 by 2, which is initially, what is the mid value? Mid value 0 plus 7 by 2, which is 3. I mean, it will be 3.5, but we'll take the value 3, integer 3. So mid comes here, mid comes here. So mid comes here. So now you can observe, you'll write the conditions this way. You observe this. Start is equals to 0, end is equals to n minus 1. While start is less than or equals to end, mid equals to start plus n by 2. Here instead of f and l, we took start and end. Now we are checking if array of mid double equals key. Array of mid means what? Array of mid means array of mid. Mid, what the value that we have got for mid? We have got 3. So array of mid. Array of 3 means what? 90. If 90 double equals key. If 90, what is the key that we want to have? 50 is the key. Is 90 double equals 50? No, it is not. But we can observe that even if it is not, we can say our key value is lower than the mid. That means it will lie to the left side of mid because they are already sorted and mid is the largest element. Key is the smallest element that we can see, right? So key will be to the left side of mid. So what we are trying to do is like we take this L to left side of mid. As we have understood that searching here has no use, so we'll take this L to left side of mid and find the value of, try to find the key 50. That is what we are doing. If array of mid double equals key, then say return mid, that we have found the mid. Else if array of mid is less than key, that means we have found that the key is a bigger value. If key is something like 100, then if it will be in this side, right? So there is no use of searching here, so we'll take this f to mid at the mid position, like at the mid plus 1 position. If it is 100, we'll take f here, but as it is, since it is 50, we'll take L here. Then we can search here instead of searching all through this, so we can reduce a lot of searching here. Yeah, this is what we can observe. And to find the time complex and when we observe the time complexity of binary search is big of log n, and big of log n is one of the best time complexities than compared to n, big of n. Now we can see, previously I have told you, right, that array is a pointer. Here we'll see what can we do with this pointer. Here we can observe, like, if this is an array and 4k means 4000 is the memory address of this particular index of this array, then 4000 plus 4, like 4004 will be the address of this box, 4008 will be the address of this box, 4012 will be address of this box. Array is 4k, then array of 0 will be like 4000 plus 0 into 4. Since it is 0 into 4 is something 0, so we are getting 4000 as the address of 0, 4004 as the address of 1. We are getting it that way. And we can say array is a constant pointer. So a pointer in the point, we know a pointer in the pointer we can do increment and decrement operations, right? Post increment and pre increment, post decrement and pre decrement. The same thing can be done with the in the arrays also, because it is acting like a pointer. So pointer in the sense, if a pointer is pointing 1, this is pointer, right? So if we are saying array means this is always pointing at the first index. Pointer plus plus, if we do, means it will come here. The pointer starts incrementing and points towards the next element. Yes, this is what actually happens. And you can also observe that we can, instead of array of I, we can also say star of array of, star means pointer, so pointer of array plus I, do that, both are same. And we can implement pointer 1 minus pointer 2 operation, but we cannot implement pointer 1 plus pointer 2. Like doing the difference is can be done, like pointer 1 minus pointer 2, but pointer 1 plus pointer 2 is not possible. Yeah, this is what we can observe. Now that we have learned some concepts like linear search and binary search, how they work, now we are trying to find out, find the solution for this problem. The problem is given like first bad version. It is lead code number, problem number 278 given in lead code. It is first bad version, and their question is something like, you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after the bad version are also bad. They are saying something like, there is a suppose that I am the product manager and currently the team leader, and I am managing a product. There will be multiple versions of a product, right? It will be like 1.0, 2.0, 3.0, and so on. Like, so they want us to and they have also mentioned that they didn't checked out, like they didn't did the quality check for the last product, and they have observed that after the last product, if they didn't check the quality, they have found it as bad, and later versions are also going to be bad, right? That is what they are trying to say here. And they are asking us, they are saying that there is a function called is bad version of version. When we call that function by giving the input like check whether 4.0 version is correct or bad version or correct version, it will return us whether it is bad version or correct version. So we have, for suppose that we have multiple versions like 1.0, 2.0, 3.0, and so on. There are multiple versions of the same product, and suppose that that version didn't got quality check for at 2.0, and at that the quality is not good. So in the later versions also the quality won't be good, right? So they have given us a function is bad version, which will tell us whether a particular version is good or bad. Here it is bad. So if a particular version is bad, then it will be bad for the next whole things. We need to find the initial bad version, like when did it got bad. Suppose that there are many versions, 3.0, 3.11, 3.21, 3.31. These are some of the versions and they are there. So they want us to find out, suppose this is the bad version. If this is in first bad version, this is good, and this is also good. And if it is bad, then later versions will also be bad. So we need to find the initial bad version. How can we find it? We can find it using like writing for loop I equals 0, I less than an I plus plus, something like linear search and all. But we don't do that because it has big O of n time complexity. But they want us to do it with minimum number of times calling the function to search whether it is good or bad. So if we want to implement this, we have already learned the concept of binary search. So we'll try to implement this. Uh, okay. Now I'll tell you how exactly we are trying to implement this. We'll take f as 1. Okay. We are not implementing linear search. We are trying to implement the concept of binary search here. And also in the binary search, we need to find the initial one. Even if we find a bad version also, this will be also bad. If we found this as bad, if we take this as the answer, it won't be the correct answer, right? We need to find the first bad version. This is the correct answer. Maybe both of them are bad. We need to check for bad, not for the values. So if we have found this as bad, we cannot return this as solution. We need to find the initial bad version. So for that, we are just taking f as 1 and l is n. Okay, we are writing a while loop. Run the while loop until f is less than or equals to l. F means first, L means last. Find the mid. If mid equals to f plus L by 2. We have found the mid, and we'll check if add. We don't have array here, right? Initially we don't have array here, we just need to, we have got the mid means something like we have got, this is version 1 2 3 4 5. Suppose that the versions are in the real numbers way, like 1 2 3 4 5 6. We need to find the first bad version. Suppose 3 is the first bad version. We need to find this. How can we find this? We have found that the mid of 1 plus 6 by 2 is 7 by 2, that is 3. This is 3. So we'll send whether this 3 is bad version or not. So we'll call the is bad version function. They have already said that they have wrote the code for is bad version. They want us to just call it. We'll call mid. If we have found that it is bad version, we are going to do, suppose 2 is the initial bad version. This is bad. We have got it as bad. So is bad version will written as 1. Yes, it is bad. But we don't know whether it is initial bad or not. So we'll do, this is F and this is L, right? We'll make this L come to here. That is mid minus 1. Okay, L equals mid minus 1. Else, if it returns as that it is not a bad version, if it is good, then no need to search over here, right? We'll take F here. So this will be bad. So we'll take F equals to mid plus 1. And then finally, the for loop runs for a while, and then finally we'll get the answer. We'll return F. Why are we returning exactly F? We'll dry run this, then we can understand it more clearly. Okay. For suppose we have the version something like 1, 2, 3, 4, 5, 6 and 7. Suppose that the initial bad version is, we have something like 8 and 9 also. Suppose that the initial bad version is this one. If this is the initial bad version, these two will be good. This is good. This is bad. All of them will be bad only. We have wrote the code for this. You can observe how we have wrote. Initially the value of f will be 1. We'll find the mid. Mid is not here. Here we'll write the index positions. Mid is nothing but 0 plus 8 by 2, which is 4. So the first mid will be here. This is mid. We'll check. We'll call the function is bad version. Is bad version of mid. Mid means here we are calling for 4. We have observed that this is bad. If this is bad, then do what we have here written, j equals to mid minus 1. So this is j in the here it means L, the last. Bring this last to this position and f will be here. Now this checking has happened once, so this while loop runs again. Since f is less than or equal to L, Again the mid, we'll calculate the mid. Mid here means 0 plus 2 by 2, which is 1. So mid comes here. It will check whether it is bad version or not. We'll say if E is bad version of 2, it will check and say no, this is not bad version, this is good version. This is good version means you don't need to enter the if condition. We need to enter the else condition and do I equals, I in the sense f equals mid plus 1. Do f equals mid plus 1. That means bring this f to here. Now again this for loop run, right? Again you run the mid. Mid means f plus l by 2. The f and l are at the same index 2. So 2 plus 2 by 2 is 2. Now again call if E is bad version of 2. Call whether it is bad or not. We have found that it is bad. So it will return 1. Yes, it is bad. It will return 1. So we'll enter into if condition, that is j equals, j in the sense L equals mid minus 1. So L again comes here. And now after this, when we again move to while loop asks for if whether f is less than or equal to L. Now we can observe that f is not less than or equal to L. F is at 2, L is at 1. 1 is less than or equal to 2? No, right? So this while condition stops and now we'll return f. And now we'll return f. F in the sense we'll return the first bad version. That's it. Yeah, this is for today. This is what I have learned. The concept of arrays today. Looking to come up with more new concept from tomorrow. Okay, bye.